Hello everyone, in today's class we're going to start a new chapter, chapter 4, which discusses forces that act, forces that are a result of static fluids. Okay, so for example, if we have a vertical wall and that vertical wall has a body of fluid behind it open to the free surface. This symbol here means the fluid is open to the free surface, which means that the fluid is in contact with atmospheric air. We'll assume that fluid to be water, and the fluid has a depth of 12 feet, call that H, whereas the center of the wall, we call that HC, which is the centroid of the wall. Okay, now we know that at this point the pressure is 0, the free surface. But when we go deeper into the fluid, we notice there's an increase in pressure, and that increase is linear. We also know that the pressure acts perpendicular to the wall. Okay? Now, this fluid is static. It's not moving. It's not in motion. Though it still has pressure acting on the wall. Now, the pressure that's being acted, it's not being acted here this is the side view of the wall. The front view looks something like this. That's looking at it from here. Looking at it from the front. This is the area where the fluid is in contact with the wall and it's pushing the wall. That pressure, now we know that pressure equals force over area. Therefore, force equals pressure times area. Okay, now this pressure here acts as a force in the wall trying to move it forward. Okay, so unless the wall is very strong, it cannot withstand that force. And this is the whole point of this chapter, is to calculate, is for you to calculate if the wall can withstand the forces acting upon it by a static fluid. Not a fluid in motion, but a static fluid that's not moving. Okay? Now, the point of this chapter is to find the sum of forces, which is called the resultant forces. And it's also to find where that resultant force is happening. Usually the resultant force happens a little bit lower than where the centroid is, and that point is called the center of pressure, or HP. And that's for you to solve in using this chapter. Okay, now the sum of forces, the resultant forces, equals, since P, the pressure, well, pressure times area. Pressure times area. We've discussed before that it will be this is the area used, which is the area in contact with the fluid, which is the cross-sectional area. Okay, whereas the pressure, since the pressure varies from the top to the bottom, from point 0, from H equals 0 to H equals 12 feet, the pressure varies. Therefore, we'll take the average pressure. The average pressure, which is happening on the centroid, which is 12 feet H over 2. Therefore, FR equals Now, we know previously from the previous chapter that pressure equals specific weight times H. Now, since we want the average pressure, we'll use the average height, which is HC. Okay? Therefore, FR equals specific weight of the fluid times HC, which is H divided by 2 times A. That is your FR. Now, HP in a simple example like this one, we'll use geometry, which, if we look at the triangle up here, the pressure is acting on the wall. It looks like a right angle triangle. It is a right angle triangle because the pressure are acting perpendicular to the wall. Okay, so if this is the triangle of pressure, which is a right angle triangle. Now, where the resultant is happening, if you take it from the bottom, if your starting point is from the bottom, it will be HP equals 1 over 3 H from the bottom. Whereas from the top, HP will equal 2/3 of H from top. And the reason behind that is because the pressures in the bottom are way greater than the top. Therefore, you would only need to go so much in order to reach where the total pressure is happening, or the sum of pressure is happening. Whereas from the top, the pressures are very small. In order to reach the location of the resultant force, you need to go deeper and deeper into the fluid until you reach the center of pressure. And the reason behind it is solely geometrics, just because, well, geometrics if you're looking at the triangle, the right angle triangle, but in terms of common sense, the pressure at the surface of fluid is 0, and as you go deeper, it increases little by little, whereas at the bottom of the fluid, the pressure is higher, so you'll only need you will need to go a certain height in order to reach the total, or the sum of forces, the resultant forces. Okay, so that covers HB. This is just for a simple example like this one. Whereas when we go deeper into the chapter, finding HP, or the center of pressure, will be a little bit complicated. Okay, now we'll stop here. We'll start another example in the next class. See you then.